Okay. Assalamu alaikum. Am I audible? Okay. So thank you for joining our today's session, which is mainly on managed care serverless offering. We will talk about what is GKE Autopilot uh, clusters, and mainly what are the different mode of operations in GKE. Other than that, we will be talking about what is EKS Fargate and how does it compare with GKE Autopilot in terms of a managed care serverless offering. And what are OK virtual nodes? How does it help manage your infrastructure, and the cost comparison between these managed care serverless offerings. Okay, so before starting, mainly I had a question. So, what? So, in past, you had used any managed kits offerings or managed kits serverless offering? What challenges that you have faced in managing your Kubernetes clusters? Anyone want to answer? Okay. Okay. Setting up nodes. All right. And scaling. All right. Scaling is a good point. Managing nodes is a good point as well. So, mainly, there are two types of offerings in offerings today. There is a managed Kubernetes offering like GKE Standard, EKS, EKS control nodes, sorry, Elastic Kubernetes Service, Azure Kubernetes Service, which are fully managed control plane where provider handles tasks like control plane management, high availability, and upgrades of your control plane nodes. But there is still a responsibility on you that you have to manage that are the worker nodes, choosing your machine types and sizes, and handling your node upgrades and patching, right? One of the managed Kubernetes, when we are using managed Kubernetes offering, we have to manage all of these things like managing worker nodes, upgrading our nodes, and scaling these nodes whenever there is a resource constraint. But if we talk about managed serverless Kubernetes offerings like GKE Autopilot or EKS Fargate or OK virtual loads, the term serverless here doesn't mean that no s- there are no servers. Um, there are servers, but it's abstracted away by the cloud provider itself. So, in a managed serverless setup, you have to manage your um, provider control plane nodes. You have to manage your worker nodes. uh, you don't have to, like, these things are managed by the cloud providers have, like, managing your control plane node, managing your worker nodes, scaling them, infrastructure, patching them, and upgrading them. You don't need to worry about machine types, uh, the node pools, or balancing workloads across nodes. So, uh, mainly, these are the two main offerings of provided by the cloud provider. One is managed kits offerings and managed serverless offering, and the differences between both two. Okay, so when we talk about GKE, when we are deploying our clusters, there are two mode of operations available to us. By default, there is one that is GKE standard. So GKE standard is your managed Kubernetes offering. in which you handle your node scaling based on workloads. You pay for all the resources you use, like the compute nodes you are using, and any other resources like persistent volumes and storage, things like that. So you, if even if you are using the whole node, if you are using like a large node, and you are only using a 10% uh, compute resources of that node, so the a lot of the resources of that node is being wasted, and but you are still paying for it. So GK standard doesn't manage your resource utilization. You have to manage that as yourself, and you have to make sure that you are properly allocating the proper node sizes and the proper resource allocation in order to save on costs. So, um, so if we talk about if we visually see what uh, things we have to manage in a Kubernetes managed offering, that is the worker node management and node pool specification configuration, control plane upgrades, OS patching, node upgrades, and control plane provisioning are managed by the cloud provider itself. So these are mainly the control plane components of your infrastructure. Okay, so so here, if you are using a GK standard mode of operation for your Kubernetes clusters, so the API server, the zonal control plane that contains the API server, cloud controller manager, scheduler, storage for that, that is maintained by GKE and is provisioned by GKE itself. But you have to manage your GCP services like load balancer, persistent days, VPC network, and worker nodes, which are hosting your applications. Okay, so GKE Autopilot. So GKE Autopilot is your managed Kubernetes serverless offering, in which mainly resolve your problem of managing your infrastructure. So the GKE Autopilot, in GKE Autopilot mode of operation, the cluster configuration, including your node scaling, security, all of these things are managed by GCP itself. You just have to uh, focus on deploying your applications, and uh, a lot of the underlying infrastructure is managed and provisioned by GCP itself. So one of the main feature is basically the resource optimization in GK Autopilot serverless offering. Um, so Autopilot automatically adjusts your resources based on your workload demands. So you there is so it ensures that you're using resources efficiently, and um, uh, it focuses on scalability on demand mainly. So you whenever you need resources, they are provisioned by GCP itself, and you don't have to worry about provisioning nodes for resource constraints. So it really helps you do scalable, help your cluster be scalable whenever there is a demand, and not when there are nodes and that are not being used, and you are still paying for that. Okay, so GK Autopilot clusters mainly manage your control plane, your worker nodes here, and the things you managed by you are mainly the load balancer, persistent days, or VPC network here. So that's how GK Autopilot resolve your infrastructure management overhead. Okay, so the features for GK Autopilot. It mainly consists of taking care of your provisioning, scaling, and upgrading, patching, and freeing you from complexity of cluster management, automatically adjusting resource allocation based on workloads demand, and abstracting the underlying infrastructure so that you can focus on application development. Okay. So if we compare it with another alternative managed Kubernetes offering, serverless offering, it's EKS Fargate, mainly provided by AWS. So EKS Fargate works on the same principle, that is that you run your Kubernetes pods on AWS, and it eliminates your need to manage the underlying infrastructure. But the difference between EKS Fargate and GKE Autopilot is mainly on how they manage things. So EKS Farg in GK in EKS Fargate, you mainly create a Fargate profile for specific namespaces that allows Fargate to spin pods on, based on that Fargate profile you configured. So, if you are using a Fargate profile of customer app, so it will configure those namespaces, those pods in those namespaces. And if you are using a default Fargate profile, it will configure those in separate namespaces. Okay. Okay, so mainly, if we talk about how the infrastructure deployment of EKS Fargate and GKE Autopilot clusters work. So in EKS Fargate clusters, you can simply create a cluster using the dash dash Fargate if you are simply using command line to deploy your cluster. So we use EKS Scuttle to deploy a sample EKS EKS Fargate cluster, which we can create using EKS Cutter create cluster dash dash Fargate. And for G Cloud, we can use the G Cloud existing CLI and just pass create auto to create our autopilot clusters. Mainly when creating these Fargate clusters and autopilot cluster, there was the main difference between both here was that GKE autopilot cluster took about 4 to 5 minutes to provision, and Fargate clusters mainly took about 15 to 20 minutes to provision, which is like 3 to 4 times more than that of uh, GKE autopilot clusters. Um, okay, but if we are using a like a Terraform configuration for deploying our EKS GKE autopilot cluster and EKS Fargate cluster, the main difference is that deploying a GKE autopilot cluster is fairly simple. You have to just define a resource called Google Container Cluster, and just enable autopilot equal to true there. The rest of the things like provisioning subnets, VPC is done by the GKE autopilot itself. This is the default behavior of the GKE autopilot provisioning method. But when we are using Terraform, EKS for EKS Fargate profile, there you have to set up the subnets, the VPC, and the EKS cluster itself, and then configure EKS Fargate profile, which tells the AWS that what namespaces EKS Fargate will be managing. So mainly the difference here is about that previously when we were using EKS Scuttle to deploying our EKS Fargate cluster, a lot of the backend things like creating subnets, VPCs, and creating EKS clusters and the Fargate profiles were abstracted, and EKS Scuttle was managing them, were creating them automatically. But when the developer or user uses a Terraform manifest to deploy these clusters, it really helps us understand that how uh, simple it is to deploy a GKE Autopilot cluster through Terraform. Other than we have to in AWS EKS Fargate, we have to create all of these things manually. uh, so there is a this the infrastructure deployment differences are there between the GKE Autopilot cluster and EKS Fargate Terraform manifest. Okay, so the next part, mainly the deploying of application on your EKS Fargate clusters. So EKS Fargate uh, mainly uses a method of provisioning VMs for each new pod. So whenever you deploy pod to your EKS Fargate cluster, based on the specific pod specification, EKS Fargate provision a separate VM for that pod. Um, so here in this EKS, here in this architecture diagram, if we are applying a deployment with two two replicas, so it will create two Fargate VMs for each of those separate pods. So mainly the problem here becomes that when deploying all of the other type of deployments for communities like stateful sets, state or a cron jobs or jobs or deployments, it works fine. But when we are using daemon sets for our applications, we can't really we can't really deploy daemon sets on our EKS Fargate cluster, since most of the pods are created separately on each separate VM. So EKS Fargate doesn't allow users to deploy daemon sets on EKS Fargate clusters. The main difference here between the EKS Fargate cluster and GKE Autopilot clusters are that mainly the GKE Autopilot cluster allow you to deploy daemon sets on your GKE Autopilot clusters. It since GK Autopilot cluster works on the concept of node auto provisioning to manage your infrastructure. So you it just deploys a separate node like a E2 medium node, or with here in the architecture you can see that it deploys whenever you apply a new port, it deploys a new node, and after that new node is provisioned, you can deploy the daemon set on that node. So whenever a new node is auto provisioned, as for example, if a new new autopilot node 3 is provisioned, the daemon set is auto scaled to that new node as well. So uh, due to which GK Autopilot is able to support daemon set deployments on your GKE Autopilot clusters. Both of these clusters mainly uh, differ in these concept of deploying daemon set, in which one Fargate clusters support deploying daemon set, and GKE Autopilot uh, does not support daemon set on EKS Fargate cluster, and daemon set are supported on GKE Autopilot clusters. Okay. Next, we can move on to OK virtual nodes. Okay, so Another alternative for GKE Autopilot clusters are OK virtual nodes, which is fairly a new offering by Oracle uh, that targets cares serverless mesh offerings for your Kubernetes deployment needs. So, what are mainly OK virtual nodes? So, virtual nodes in OK mainly works on the concept of virtual nodes, that is a CNCF project of the CNCF project, which is mainly called virtual kubelet. So what is virtual kubelet? Virtual kubelet is mainly so when we are working with the traditional Kubernetes clusters, the kubelets are deployed on each VM, which manages your infrastructure VM backend. Works as a VM backend basically. So virtual kubelet, what it does, it creates an abstraction layer between Kubernetes and underlying infrastructure. So the kubelet mainly manages your VM, but the virtual kubelet uh, mainly. Uh, so, for example, if we have a GCP cloud, when we deploy a VM from GCP cloud, that is EC2 instance, oh sorry, GC instances for Google Cloud. So we provision the nodes from the Google Cloud and then deploy plots on them. But what virtual kubelet does, that it um, uh, like manages your pods directly and provisions the node on top of that virtual kubelet. Okay, so if we okay, there is a diagram here which will help you understand. Okay, so for example, if we are using virtual kubelet architecture of EKE virtual nodes, whenever we create pod, the request is sent to the virtual node, and then the kubelet API asks the container instance CI, which is the backend for virtual nodes in OK, to deploy our clusters, to deploy our pods. So mainly virtual nodes is single nodes on a single virtual node, a single node on which we can deploy thousands of pods. So a virtual node acts as a abstraction layer between the container instance CI running our pods and the how we deploy our pods on the Kubernetes itself. Okay, so okay, virtual nodes. Okay, wait. So Oracle uses the OK virtual nodes concept and uses OCI container instances to deploy your Kubernetes pods to run your pods and manage infrastructure on top of a virtual node concept. Okay. So when it comes to managing the costs between your EKS Fargate, EKS virtual nodes, GKE Autopilot, and OK virtual node. So there is an offering by Azure also itself that uses the virtual nodes concept to run your Kubernetes pods. If we talk about cluster management fees from all of these offerings, the EKS Fargate, EKS Virtual Node, GK Autopilot, and OK Virtual Node cost the same. That is $0.10 per hour cluster management fee. And but OK Virtual Node like charges you more per node per node, that is $0.015 per virtual node. So when we talk about resource cost between all of these clusters, between all of these clouds, the OK virtual nodes fairly costs less than that of the other clusters, that is EKS with Fargate or EKS virtual node or GKE Autopilot. So, for example, if we are deploying a cluster that we can, I have created a formula here. So, for example, if we have X number of cluster per price per hour and daily cluster per hour. So, for example, if we want to run 20 pods for 31 days configured with 16 vCPU and 64 GB memory using um, 32 or a bit architecture or Linux images. So going through all of these cost comparisons between all of these clouds, okay, virtual nodes would be costing you around 4K USD for this scenario, and GK Autopilot and AKS virtual node, EKS Fargate will fairly be equal in pricing, and GK Autopilot will cost you 15K for running 20 pods on for 31 days on 16 vCPU and 64 GB memory. Okay, uh, so when we are using care serverless offerings for our needs, there are some limitation when we are using care serverless offering. That is that there is no daemon set supports on most of these serverless offering except GKE Autopilot. In GK, in the serverless offerings, you can SSH into nodes if there is any requirements for you to look into the nodes configuration or manage node configuration, or you can't really troubleshoot performance related to nodes. So serverless, since all of these nodes are managed by the cloud provider itself, so you can't really have control over your nodes. Okay, restricted pod capabilities. Whenever we are creating our pods on the serverless offering, we can't really um, create privileged pods for so if we are using any privileged pods for our application, that is our application requirements, or if our infrastructure requirement, so privileged pods are not allowed on all of these serverless offering. um, since all of these nodes are managed by your like your cloud providers, you can't really con- do customizations or have control over scheduling or networking or node configuration, which could limit your use cases on if you have things around having specific scheduling needs or networking needs, all that. So okay, so mainly the summary is that if we are using the serverless offering or the managed care serverless offering, a managed offering or managed care serverless offering, we need to like weigh our pros and cons on what type of infrastructure needs do we have. If we do we have any daemon set requirements, or do we need to set up any specific node customization, or do we need to have our uh, control over our nodes. So uh, in that case, in use cases, we can't really use Kubernetes serverless offering by these providers, and we have to go for managed Kubernetes offerings. But if we are using, but if our use cases is setting up. So if we want to reduce our management overhead, that is, new startups want to set up uh, infrastructure around Kubernetes without having a large management overhead, that in there so in those use cases we can use these managed K serverless offering, that is EKS Fargate, OK virtual nodes, and um, GKE Autopilot offerings. Okay. Um all right. So, do we have any questions for around these uh, presentation or TUI? Okay, Mary.
Thanks, Oli. This was pretty detailed, a lot of different resources and services. I had a question regarding Fargate actually. When you were presenting that, you mentioned that Fargate took about 15 minutes to deploy, and then GKE Autopilot took only 3 to 4 minutes. So,
Mhm.
do Fargate deployments take that much time every single time you do that, or was that just the initial setup time?
No,
Like if I
it
make
was the initial
changes.
setup time. So after deploying the EKS Fargate, there was like no delay between scheduling between GKE Autopilot and EKS Fargate.
Makes sense. All right. So if I make changes to my code base or to my application resources, it shouldn't take as much time every time.
Yeah. So after after the initial deployment, it wouldn't take much time scheduling your pods or application on EKS Fargate.
Mhm. Got it. Thanks.
Okay. Any more questions? Okay. If we don't have any more question, we can end this presentation, this TUI. Thank you for joining all. Allah Hafiz.
So